suppose I wanted to travel from the center of the St. Louis metropolitan area to Soroka, Japan. Notice that Soroka, Japan and St. Louis are about the same amount north of the equator. They're both about 38 degrees, 43 minutes, and 42 seconds north of the equator. If I wanted to travel on their shared circle of latitude, I'm finding the arc length from this location to this location. One issue to keep in mind, though, is that circle does not have the radius of the Earth as its radius. This circle is smaller. Notice it's at a different position on the sphere of the Earth, and that circle is smaller. So first, if we wanted to find this arc length, we would need to find the radius of their shared circle of latitude. Now, I would like to mention that this would not be the actual shortest distance between these 2 points, because that would be the distance on the great circle that contained them. There's actually a great circle that would kind of go catty corner between those 2 points and wrap around the other side of the globe, and that distance would actually be the shortest distance between them. But suppose on our travels we wanted to stick at the same line of latitude, so we're going to travel on this arc of latitude. Another thing to point out is that Soroka, Japan is east of the prime meridian. So here's the prime meridian going through the United Kingdom and France and Spain and parts of Africa. If I go east into Eastern Europe and across Asia, Soroka, Japan is 139 degrees, 49 minutes, 32 seconds east of that prime meridian. St. Louis, on the other hand, is west. So we would go across the Atlantic Ocean, across the East Coast to the center of the United States, and St. Louis is 90 degrees, 19 minutes, 55 seconds west. Now again, I'm picking a specific point in St. Louis and a specific point in Soroka, Japan. So notice that arc length from the measurement of its eastern longitude to St. Louis's longitude is a bigger portion of the circle. If we really wanted to find the shortest distance on their circle of latitude, we would actually have to find this backside arc. It's actually smaller. And that's because that location in Japan is so far east. It's so far east, it's almost to the international date line, which is the other half of that prime meridian longitude circle. But let's first find the radius of their shared circle of latitude. To find this radius, we need to be able to visualize a right triangle with a segment straight into the Earth's center as one leg and a segment in the plane of the latitude circle as the other leg. The hypotenuse of this triangle is then the radius of the Earth coming out of the center to the surface of the Earth at the correct latitude. And this hypotenuse length is approximately 3,960 miles. That's approximately the radius of the Earth. The horizontal leg of this triangle is the radius of the latitude circle that we're looking for. Now let's explain some of the values that were in our diagram so that we can actually find that leg of the triangle, which is the radius that we're looking for. The latitude of St. Louis and Soroka, Japan is 38 degrees, 43 minutes, and 42 seconds. Let's convert that to decimal degrees. Remember, there's 60 minutes in a degree, and so we want to divide the 43 minutes by 60 to get the correct decimal for the minutes, and there are 3,600 seconds in a degree, so let's divide the 42 seconds by 3,600 to get the correct fraction for the seconds. So adding the 38 whole degrees to the fraction 43 over 60 to the fraction 42 over 3,600, we get the decimal degree of 38.7283 degrees. That's the latitude, or the rotation north from the equator, that these two cities are located. But the angle that we want in our triangle is actually 90 degrees minus that angle. Notice inside the triangle is not the latitude, but the complement of it. So 90 minus 38.7283 gives us the angle in the triangle, 51.2717. There is a function of an angle called sine, and sine of an angle in any right triangle is equal to the ratio of the opposite side to the angle divided by the length of the hypotenuse. That's exactly what we need here. We have the hypotenuse, it's the radius of the earth, and the opposite side to the angle theta is the radius that we're looking for. Our angle theta is that 90 degrees minus the latitude, the 51.2717 degrees. So sine of 51.2717 degrees will be equal to the opposite side, which is the radius of the circle we're looking for, divided by the radius of the Earth, which is 3,960 miles. To solve for the numerator, for the radius, we want to multiply both sides by that denominator. So if I find on my calculator sine of 51.2717 degrees, make sure your calculator's in degree mode, and I multiply that value by 3,960, I will get approximately 3,089.2811 miles. That's the radius of the circle of latitude that St. Louis and Soroka, Japan share. The distance between our cities is going to be a fraction of the circumference of this circle of latitude. So let's find the circumference. Remember, the circumference of any circle is 2 times pi times the radius of the circle. So if I take 2 times pi times 3,089.2811 miles, I get approximately 19,410.5 miles. That's the circumference if we went all around the circle of latitude that St. Louis and Soroka, Japan fall on. Before we do our last step to actually find the distance between our two cities, we need to find the angle between the two cities. If we convert the longitude of Soroka, Japan, which is 139 degrees, 49 minutes, 32 seconds, to decimal degrees, we get 139.8261 degrees. Soroka is east of the prime meridian, so that's a positive value. St. Louis's longitude is 90 degrees, 19 minutes, 55 seconds west. If we convert that to decimal degrees, it will be 90.3319, but it's a negative value because western locations are considered negative. If you then find the difference, hence the subtraction of 139.8261 and negative 90.3319, you will end up adding those two magnitudes, those two values, and you will get 230.2 degrees. But that's more than a half circle. So there's a smaller angle between them, which is then 360 minus the 230.2. So 129.8 degrees is actually the smaller angle between our two cities. The distance between Soroka, Japan and St. Louis will be a percentage of the full circumference. So to find that percentage, take the angle 129.8 and divide by 360. That gives us the proportion 0.36. 0.36 is 36%. So we want 36% of that circumference that we found earlier. So 36% of the full circumference of 19,410.5 miles gives us approximately 6,988 miles, which I guess we could probably round to about 7,000 miles. So if we rode our little scooter and dinghy from Soroka, Japan to St. Louis, we would have to travel about 7,000 miles. This is a good problem to think about how math is about thinking. You don't want to just memorize the steps of a problem like this. Instead, every little step, every slide, we were reasoning something out. Every step was not that complicated. It was basically, pre-algebra math, then with the definition of sine, but you had to pay attention to what each number meant and what you were doing. And that's true for all math. You should have a conversation with yourself as you're doing all of your problems, and that conversation should be a continuing of, I am doing this because, and have a reason why you're doing each step. Don't just blindly look at some problem that somebody else worked out and say, oh, look, they added here, so I'm going to add. Like in this case, we sort of added the two angles to get the 230.2, and then we subtracted that from 360, but that was because one location was east and one location was west. You could do a problem similar to this where both locations are east or both locations are west. And in that case, you're just going to subtract the two values, and that will give you the angle difference between them. So when you're doing all math, remember it's about thinking and problem solving, and so you should constantly be having a conversation. I am doing this step because, and then fill in the because with a reason that you understand. And if you don't understand, then you need to ask.